Okay, here we're going to look at an electrocardiogram, sometimes abbreviated ECG or EKG. And we're going to get appreciation for these little peaks and valleys and what these actually mean and how they indicate what's normal for a properly beating heart. So starting in general, like other muscles, the heart muscle contracts when stimulated, and an EKG shows heart's electrical activity. So it's electricity actually moving through the heart. We're looking at the heart cells depolarizing and repolarizing, and that's what we're seeing with these little kind of peaks and valleys. They're all labeled, and we're going to go over each section and what it actually means. This is a good kind of general summary. We have something called a P wave, that's the depolarization of the atria in response to the SA node triggering. Then the PR interval here is a delay of the AV node allowing the filling of the ventricles. The QRS complex is a depolarization of the ventricles triggering the main pumping contractions. Notice it's a big peak here. It's a main contraction phase here. The S to T region is the beginning of the ventricle repolarization. It should be generally flat. And the T wave here is the ventricle repolarization. So we're going to look at these in just a little bit more detail. But you can see these distinctive regions are all labeled, and so are certain segments and complexes. So to kind of get that into motion, when we look at kind of our peaks and valleys, this I know it presents it a little bit fast, but you're welcome to pause it here. But the heartbeat originates at the SA node. It's the cyanoatrial node, and it's abbreviated SA node. And this is spontaneously depolarizes. This wave of depolarization spreads to the atria, causing them to contract. So we see that initial kind of signal here, right there, going right to here. This second portion right here, this is the AV node, or the atrioventricular node. This passes the ventricles via the bundle of His and is conducted rapidly over the surface of the ventricles in the Purkinje fibers, as we see here. Ventricle contraction empties the heart. And if we notice here, our atria contracting first, and then followed by both of our ventricles contracting. This is a diagram of the heart with all the muscle removed, just looking at basically the conductive nerve fibers here in the heart. Again, this kind of shows the waves that are occurring simultaneously with the beating of the heart. Now, understanding in ECG here, the P wave, where the atria are full of blood and the SA node fires. That's what we see here with the P wave. The PQ segment is the time it takes the signal to travel from the SA node to the AV node. There's a little bit of a delay there, and that's important. We don't want the whole heart contracting at the same time. Continuing on that, we have the QRS complex, and that's the firing of the AV node and the contraction of the ventricles. Keep in mind the ventricles have to pump blood all the way to the lungs and the body. That's why we see this large peak there. The R wave is the main mass of ventricles contracting. So specifically within the QRS complex, that R wave is the main mass of the ventricles contracting, followed by the ST segment located here. It's the interval between the ventricle depolarization and repolarization. This is a flat region. Okay, not much is happening. There's a little bit of a delay process, leading to the T wave, which is the repolarization of the ventricles. We see a slight increase there. In addition to the description I'm giving you, there's also a couple other videos here that you're welcome to look at. These electrical signals, again, putting kind of a picture into colorization of the wave. We see the SA node here. It's our first little bump. Then we're having our impulse going to the AV node. That's that flat line here. Then we see the bundle branches carrying the signal. That signal's being passed down here, reaching all the way to the heart apex, which is the bottom of the heart. We see that right here. And then when our ventricles contract, this entire area, that's our big peak here. So again, tying in what's going on with the actual heart with the actual sections of this wave are very important. Putting this in a little bit of more of a circular form, you can see here, it's the same basic PQRST sequence, just putting it in a circular form, because again, it does reoccur again and again. So some representations here, provide it in a circle, giving that cyclical nature, and we could see the exact same sequence, again, tied in with the P, Q, R, S, and T waves and segments of the cardiac cycle. Lastly, these are becoming more popular, more prevalent. We have seen this sign at airports or public areas called AED. This stands for Automated External Defibrillator. It's a portable electronic device that applies electricity, which stops the arrhythmia, allowing the heart to reestablish an effective rhythm. What's great about these is they're fully automated with simple audio and visual commands, and they're designed so basically anyone can pick them up. However, their use of them is being taught in many first aid and CPR classes. So if you've gone to one of those classes, you may have had experience with these, but they are in very public areas, and they do have a very stepwise walk you through the process sequence here. So you may have been familiar with these, and this is a way we could restart the heart if someone did have a potential heart issue in a public area.